So what I wanted to showcase here today is this concept known as the EnabledRefRW. So the problem this solves is for when we're dealing with enableable components. So real quick, let me just show you kind of this enableable component that I have. I wanted to bring this up for the cache it because I do think that it is a useful thing, something that I was just recently reminded of as I was kind of going through some forum posts, because it isn't something that I had really used all that much. But I definitely do see the kind of use for it. However, there are some kind of drawbacks that I wanted to bring up in this section as well. So anyways, we have this player sprint multiplier here. You can see it's an iComponent data, and it is an iEnableable component. So, and you see that I just have a public float value on here. So the idea is that we would set the value of this player sprint multiplier, and then basically in our player input system, we would enable this component, and then basically if that component is enabled, then we would apply an additional multiplier off of the player's base movement speed to make them move at their sprint speed. So, if the sprint multiplier was 2, then they would sprint, 2 times faster than they would walk. And this would basically only apply if this component was enabled. So anyways, what I've done here is I have this player input system, and then you can see that basically we're just, checking to see if the sprint input is pressed here. Now, so this is inside just an idiomatic for each, and I'm kind of showcasing 2 different ways that we can actually enable components. So typically the easiest way to do here is just using the system API.setComponentEnabled, and you can just pass in the type, which entity that it's on, and then you can pass in true or false here. And then again, this jump input, we're just kind of using just reading from that input map there. So anyways, a couple differences here is we can also do a, when we're defining our query here, you can see that I have this EnabledRefRW player sprint multiplier. So again, basically what this does is it gives us access to the enableable portion of this player sprint multiplier. So what we can do here is just do our player sprint multiplier dot value RW equals sprint input. So we can just kind of set that, true or false to there. I think one small advantage of this is we don't need to actually declare that we need entity access. Whereas, with the system API.setComponentEnabled, we just need to pass in the entity as well. Whereas this, because it's part of our query, we can just directly modify that there. So wanted to point this out because I think it is a handy thing to do. And really where it comes into really one of the benefits of it is using this in an iJob entity. The reason is because in an iJob entity, you actually don't have access to this system API here. So, one of the ways that I had kind of typically done setting components enabled or disabled inside of an iJob entity is using something like an entity command buffer, which, may not always be the most efficient thing, because if we're, say, enabling and disabling lots of things, we're going to kind of have to queue up all those operations into an entity command buffer, and then we have to play those back, linearly on the main thread later on, which is, maybe not always the most efficient way to go about things. So what I've done here is you can see inside the execute method, one thing that we're defining is the EnabledRefRO, the player sprint multiplier. And this time we're using the refRO because in this case, we're just reading whether this player sprint multiplier is enabled or disabled. And then we can basically apply inputs on that. So you see that we can just do this if player sprint enabled dot value RO, and then we can actually apply the multiplication logic in here. Now, a couple things about where this falls a little bit short, in my opinion, is you can't actually directly access the underlying value using this enabled refRO player sprint multiplier thing here. So you actually have to define a separate, the component itself separately if you want to access that underlying value. So you say, in player sprint multiplier player sprint. And then so here, once we determine if it's enabled, then we can access that player sprint here. We get our multiplier, and then we do our final speed multiplication here. So it's one of those things where it's like I kind of wish that maybe there was a better way of accessing the underlying data with the EnabledRefRO. And also just kind of like looking at this here where it says, player sprint enabled.value RO, and then there's like nothing after that. It's just a little bit different because when we're inside, say, entities.forEach, and we're using the refRW let's like this player move input, you see that there's something after. So it's like the player move input dot value RW dot value, and then that's when we're kind of setting the move input. Whereas with just the enabled ref RW, then there's like nothing after that. Like the enabled and disabled is just kind of like this value RW. So it's just a little bit different than that, kind of pattern that I can say that, I'm kind of used to. So, maybe it would be nice if there was like, say, a like dot enabled, something like that there. And then also on that, it would be nice to just like say, get the underlying value just like this. But yeah, maybe we can kind of talk about why that kind of is the case. And one quick thing that I do want to point out as well, we do also just have to add this attribute up here where we have the entity query options of ignore component enabled state. And so that basically means that, it doesn't matter if, this player sprint multiplier component is enabled or disabled. This system is always going to run as long as, that player sprint multiplier is on that entity. So yeah, that's kind of the cache hit that I had as I, just wanted to bring up this whole concept of the EnabledRefRO / refRW, and then just kind of rant about it a little bit about how I think it can be improved. But do you have any thoughts on kind of what I was just saying there?
Well, definitely for one, like as ITR also mentions, component lookups and buffer lookups, etc. Everything that has an enableable state can also the related lookup has the ability to set the state and also check the state. So you can use the component lookup. Also, a chunk can also get to know that information. So if you're writing this out in an iJob chunk, there is a way to get both, because it is actually just a Boolean flag on the chunk itself, a v128, which is also why the max on a chunk amount of entities is 128. Because it's like how we flip, saying whether or not it has it. But anywho, I do think it's a little annoying that you can't get the value along with it. I don't think it necessarily that the information needs to be a dot value. Maybe it should just be a instead of value RO and value RW, it should be like enabled. And since you're already getting a RW, it can check that you're setting it or you're writing to it.
Right.
Yeah, I think partly it was because initially you could use the read-only in a place where it didn't make sense for it to be writable. There was some, like, we were afraid you might store the value and keep it, and then you don't check the atomic safety handles that are inside. Because if you look at an enabled refRO, we actually store an atomic safety handle, making sure that you have, valid access to it. But it is annoying that you can't just get both. But I don't think there's a better way. I think that's the way.
Yeah, it makes sense, I guess, because But yeah, no, there are kind of other ways to go about things, but again, it would be nice, in those cases where I might want to access, both whether it's enabled, or actually get the underlying value, and then also not having to define an additional component lookup Because again, and then with the component lookup, then we
Well,
would
it's not
also
actually
have
going to
to.
result to an additional lookup. Like if you go press the dots thing that is just beside iJobInst, that one, and show generated code, you can see that it will actually not do an additional checkup. And the easiest way to tell that is if you scroll down to line 32, you can see it does get enabled refRW. So it already has found the chunk. So it doesn't actually do an additional lookup. If you were to use a component lookup, it would be an additional lookup.
Okay.
Yeah. So it is more efficient this way. It also means that you can. One of the reasons that it was done this way is so that you don't have to get the whole mask if you're not planning on using it. But I think it wouldn't actually matter in the end because it's so little data. So
Right.
we'll see. We'll have to test around with it at some point.
Again, it's just kind of one of those small little, quality of life coding things that can just save you a couple extra keystrokes, really.
Also, I can see someone is asking the question of if it is per chunk, how does enable disable not cause a structural change? Which, because it is per entity, that state, as long as you're only modifying that state, it is just a field that is already allocated. Like the component ahead of time knows whether or not it's enableable. And so it knows whether or not it needs to store for a given chunk a bit field, a bit mask for that given chunk. So yeah, that's why it's not a structural change. So you might want to, if a job is writing to it, you do need to complete in order to actually figure out how many match a certain query. That's also why you have to complete any entity query dot calculate entity count if that query happens to contain a enableable component. Because otherwise you wouldn't know if anything has changed around the state.
Nice. Sounds good to me.